Okay, we divide up our probability into part A, part B, etc. This is the beginning of the review for the part A test. Okay, and here's some greatest hits. You got a Venn diagram. And I want to show you how sometimes you can figure out what goes where, because I would say in past tests I've marked these wrong more than almost any other. If I give you some info like how many of you like tennis? Raise your hand if you would say, I like tennis. Seriously? Wow. Okay, 2 people maybe? All right, that's not enough then. I'm not going to use tennis. How many of you guys have shoes that are predominantly black? Raise your hand if your shoes are generally black. There's a lot of people with black shoes. Okay, that'll work. And then the other thing I know this one to be a fact. A lot of kids have dogs. And so we're going to do the overlap of dogs and black shoes. Now, there's 2 tendencies. If I said there's like 12 people with black shoes, everybody wants to write 12 right here. No, you can't do that. That's a tendency. The other tendency people have is if there are 3 numbers up here, 4, 1, and 7, people are all obsessed about that one, that one's like the most important one. Well, it depends if you're doing a union or an intersection. Okay, so don't just get all locked in on that number. All right, so here's some practice with making a Venn. I'm not going to ask about that overlap part. If I did, it would make it really pretty easy. Okay, so I'm instead going to ask how many of you have a dog? Raise your hand if you have a dog at home. And I'm going to count, and I'm not looking at shoes because it doesn't matter to me right now. I'm just asking about the dog. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 people with dogs. You better not put that in the diagram yet because you don't know how that 18 is divided up. All right, next, I want to know how many of you guys have black shoes on? Raise your hand if your shoes are majority black, like they might have a white stripe or whatever, but they're generally black shoes. 1, 2, 3, 4, 5, 6. Notice I'm not putting it here. I am putting it here. All right, last thing is, how many of you do not have a dog and you do not have black shoes on? 1, 2, 3, 4, 5, 6, 7. Where does that go? That little dash 7 down there. Now, the last thing we need to know is how many people total are there. I will just simply count you all. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 27. There's 27 of you in here right now. So I like to put that up here. I don't want to put it down by the 7 or it might be confusing. So there's usually nothing in the upper left-hand corner. That's a good place to put the total. Now, figure out all the rest of the spots. You have all the information you need. There's usually a few kids who are like, no, it's impossible because I added them up. And 18 plus 6 plus 7 is more than 27. It is more than 27, but that doesn't mean it's impossible because some people are in both groups. All right, you need to struggle with this for a minute, so give it a shot and try to find some combos that would work. All right, so here's how you'd kind of try to figure it out. I think, let's say that there was one person. I don't know how many people there are, but let's say there was one person. Then do you get everything else would have to fall into place? If I just pick one, if I told you it was one, do you get right away you'd be able to say, oh, then since there's 18 total, there must be how many here? 17. And since there's a total of 27, you could look at those and say, okay, how much is left for black shoes? That's a way to do it. But then that can't work because black shoes is supposed to be 6. Or another way to say it is, if this has to be 1, then these together must make 6, so that must be 5. and then you add up the 17 and the 7, which is 24, plus another 6, and that makes 30, but they're supposed to be 27. Didn't work. So what was my assumption at the very beginning? That there was a 1 there. I just assumed that. So is there a 1 there? No, that's the one thing I can prove is not right. Okay, so then who figured it out? Raise your hand if you're even more confident than ever. All right, then what do you say in the back? Miss K, were you raising your hand or are you not raising your hand? Okay, GJ, were you raising your hand? All right, what do you think it is? Yes. All right, and if that's 4, then this must be 14 because they total 18, right? And if this is 4, then since these two make 6, that has to be 2. And now how can I tell if she's right? Add them all up. What should they add up to? 27. And they do. So nice work. You see how we did that? All right. So making a Venn, one of the things that's not super easy, but you can keep trying until you get it right. Okay. Next. Now that we've got these numbers in here, and this is a real, survey from our class, didn't just make it up. If I grabbed a random kid right now, what's the probability they'd be wearing black shoes? Remember, this is our total, just to save you some time. Probability B. I'll keep it simple. Do you get a really common mistake answer that's like a face palm for the teacher is like 2 out of 27? People always think 2 is the people with the black shoes. Well, because it kind of is, but the right answer is actually what? 6. 6 out of 27 because all of these people have black shoes. So 6 out of 27 is what you should have said. All right. How about not B? Not B. Now, kids have gotten this confused before by thinking, well, you said that you couldn't pick from people who have black shoes. No, I did not say given. I never said given. I didn't say given that they don't have black shoes. I just said, what's the probability I will pick somebody with black not, as in not black shoes. And therefore, it's these 2. Those are the ones that are possible. No, sorry, those are the ones that I wanted out of 27. So 21 out of 27, raise your hand if you had that one right. Awesome. Okay, now we got to understand those union and intersection symbols. And this is where, well, first it won't be too bad, but then it'll get a little hairy. Dog, intersect, black shoes. Find the probability of, I pick a random person, and they have dog, intersect, black shoes, whatever that means. Hopefully you know what intersect means. I always think of intersection like a street intersection. Helps me to think of what it means. Here's dogs. Here's black shoes. And another way to think of it is this. I kind of like this way. Would you agree that right now, both things I circled are the people that have dogs? And now I'm going to circle the things that have black shoes. Those 2 are the ones that have black shoes. If you're looking for that, you're looking for the one where they overlap. Okay, so the answer was 4 on this one. 4 out of 27. Notice I never said given. As soon as I say given, it won't be out of 27 anymore. As soon as I say given that it's got to be a person with black shoes, it won't be out of 27. All right, but until I say that, until I say given, it's always out of 27. All right, so not dog intersect black shoes. Not dog. And the way I maybe think about it is like circle all the things that you think are not dog, and then circle all the things that are black, and then try to figure out what that symbol means. These 2, not dog. These 2, black shoes. Does that symbol mean that I'm supposed to find where they intersect? Yep. Final answer, 2. And therefore that's not probability though. So 2 out of 27. Okay. Now here's where it gets much rougher. I'm going to change it to union. I'm going to say black shoes not, union, dog, bud. Pause for a second. Let me give that a try. How many of you are confident in your answer? Four people. All right, so that's, I'm telling you, these are hard. That's why only 4 people are confident. I bet you if we actually checked, at least twice that many would actually be right, but you maybe aren't confident. And there's going to be a bunch of people wrong. Pay attention so that this isn't you on the test tomorrow. All right, so here's what you do. You find what's not B, what's not black shoes. Not in that. And I like to think of it as I just send out invites to those guys. They got invited to the party. Those are the not B's. Okay, next, I'm going to go invite my D's. Here are the ones that are the dog people. Now, again, everybody's patterned into looking for where they overlapped. Nope, it's not the 14. It's the 14 and the 4 and the 7. 14 plus the 4 plus the 7, and it's all out of 27. And there's a lot of people get confused, like, you said it was not dogs, though, or no, not black shoes, so how come it's out of 27? Because I never said given anything. I never said given that they have black shoes. That would change it. All right. Union is a big group. Notice this symbol right here does not mean where do they intersect. It's did they get invited by anybody? Think of it as 2 separate people inviting for grad parties. Some people sent out the blue invitations. Some people sent out the green invitations. And anybody that got any kind of invitation gets to come if it's a union question. So all of these, this and this and this, all of them got invited. All right. Now I'm going to change it to a given question. This will make it completely different. Because as soon as I say given, what has to change? The denominator. All right. So what's the probability of dog given black shoes? What is the probability you will pick a dog person given that they will have black shoes? That means you're only going to ask the black-shoed people. Get a fraction. Compare it to the kids near you. See if they have the same fraction as you. Okay. Given black shoes, I like to cross out the other ones. And you're going to have a test that's a paper pencil test tomorrow, and you're going to have a pencil. And I guess you theoretically could use a pen. Bad day for pen. I would definitely use pencil. And then I would like cross off lightly the things that it can't be. Because given means it must have 4 or 2. These are the only 2 that can work. So now your answer obviously better be either 2 out of 4, or sorry, 2 out of 6, or 4 out of 6. Or I guess it could be 6 out of 6. What do you think the answer is? What did we want? We wanted dog, and it's always what you want over what's possible. What's possible was 6 things. What do we want? We wanted dog, and these are the only ones that have dogs. 4 out of 6, which does reduce to 2 out of 3. Raise your hand if you had that one right. Okay. Any questions? Yes. You should reduce fractions whenever you can. Although on the test, I believe we are giving all our answers as a decimal, and therefore you won't have to worry about it too much, because if you had divided 4 divided by 6, you'd get the same exact thing as the kid who divided 2 divided by 3. But if you want to be generally right, just so that you can lord it over Will, you are correct that you should reduce. All right, good. Okay, so I'd like to do the hardest kind of them all. You ready? Let's see if you're ready. What is the probability of not dog intersect not black shoes given dog? Given that they have a dog. There's a whole lot of double reverses going on here. Not this and not that. It is confusing. Fight through it. Compare with the kid next to you. Would you agree that as soon as I said given D, this and this weren't possible? Are you with me so far? If as soon as I said given D, those two are out. That's what you should do. Now you won't by accident use the 2 or the 7. If you did it wrong. Okay, next. How about the not dog? Well, wait a minute. Not dog, I can't even use this or this. There's none of those. Okay, there aren't any not dog people even possible because we're only going to ask people who had a dog. So then how are you supposed to do that? Intersecting with not B. All right, so this one is no solution or 0 probability. Raise your hand if you figured that out. Awesome. Now I'm going to change one little thing and it will be possible. Make this a union. Now it is possible. Some of you are like, but there's still no people. Okay, but there's a union symbol, which means it's a big group. You group up everybody who's this and everybody who's that, and then the thing that helps the most is that I crossed off the 2 and the 7, and so you're not going to by accident use those. That's what people do when they get these wrong, is they use the wrong numbers. You can't use the 2 and you can't use the 7. So, what's this? Not dog. But wait, there aren't any of those. You're right. So I union that with, which means just add it up with the not B's. Which are the not B's? These guys. So it's 14 out of, which ones were even possible? These two. 14 out of 18. Raise your hand if you had 14 out of 18. Good job. Okay. I know, it's getting pretty twisty-turny. So now we got to make a chart instead of a Venn diagram. Okay, on chart ones, I think they're easier. Most kids do better on these. I want to make a real world one again. There's male and female, and then there is people that, if they were given a choice between chocolate ice cream or vanilla, I know some of you like both, but if you were given a choice, that means these aren't that good at people who like both. You have to pick one. Okay, so which one do you want? And if you're like, oh, but I like them equally, you like McDonald's because they have the twist code, you know. But that's not what we're doing here. You have to have either chocolate or vanilla. All right, and then we'll use this data, and we'll get totals, and we'll use them to answer questions. All right, who in here is a male person who would choose chocolate? Male person who would choose chocolate. Ice cream. 1, 2, 3, 4, 5. Who in here is a male person who would pick vanilla? A 1 and a 2 and a 3 and a 4. Who in here is a female person who would choose chocolate? 1, 2, 3, 4, 5, 6, 7, 8, 9. And female person who would choose vanilla? 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, tie. Let's have a big fight between the chocolate and the vanilla people. All right. Now, here's the question. If I picked a random person, notice I did not give you a given then. If I picked a random person, what's the probability that they would like vanilla? And some of you might like your totals. I'll help you with some totals here. 9, 18, 13, and 14. And the total is that you could add either direction and get 27. What was the question again? If I pick a random person, what's the probability that they would like vanilla? Did you say 13 out of 27? Raise your hand if you did. Okay, awesome. Now listen to how subtle the difference is here, and it totally changes the question. If I picked a random male, what's the probability they would like vanilla? As soon as I said random male, all of this was gone, because that's like saying given. And it can't be out of 27 anymore. When I said random male, I didn't mean a random person who turned out to be a male who liked vanilla. It was random male. Okay, so then 4 out of 9. Raise your hand if you had that one right. Awesome. What's the decimal for 4 ninths? 0.4 repeating. Very good. How about 5 ninths? 5 repeating. How about 9 ninths? 0.9 repeating. Very good. Oh, it is. Okay. So, we can have that argument a different day. How about given I'm only going to choose from the vanilla likers, what's the probability it would be a male? Don't say it, write it. If I'm only picking from people who like vanilla, what's the probability it will be a male? Well, I know some of you have zeroed in on vanilla male, and you know it's 4. Vanilla male. It sounds like Vanilla Ice, except different. Best rapper ever. 4 out of the vanilla likers. 4 out of 13. Raise your hand if you had that one right. Okay, good. See, you're getting all these right. At least most people are. So I don't think these are nearly as scary. Okay, then, last but not least, let's say you got a triple then. And it's chocolate, vanilla, and strawberry. And let's say that changed everything, and it goes like this. Now, there's only 24 people because apparently somebody ran screaming out of the room because the choice was just too difficult. So there's 24 in there. What is the probability of C union V? Oh, wait, there's more. Intersect S. C union V intersect S. I never said given anything. There's no given. C union V intersect S. Your answer is a fraction. Does that help? All right. Here is C union V. Everybody who got invited to either C or V, that's C union V. Now, where does that intersect with S? That's the question. Do you get that all the red ones are C union V? I know a lot of people think it's just the 1 and the 3. No, that would be intersect. C union V is all the red ones. Now, S will be all the green ones. But we want now to know where they overlap, because that's intersect, because that's this. And that is, where do they overlap? The 4, the 3, and the 4. That makes 11 out of 24. Raise your hand if you had 11 out of 24. Ooh, less than half of you got it, and I understand. These are tough. Why is it 11? Because 4 plus 4 plus 3 adds up to 11. Okay. That's really right. Any questions about it? Like, why is this one in there? Or you can ask if you have a question. Is that a question? Not a question. Okay. All right. Then let's try one more like that, where you do the part in the parentheses first. All right. This is going to be C union S union V. C union S union V. I better get the red off of there so it doesn't confuse you. C union S union V. And I can make these so difficult that probably only one kid can get it right. I'll give you the ultimate challenge in a minute. Here's C union S. Do you agree that's the union of C and S? Then, where does that intersect V? Well, here's V. 8 out of 24. Raise your hand if you had 8 out of 24. Oh, you don't agree, or? Oh, I did intersect. You caught me. I did intersect. That's a union at the end. Union means everybody who got an invite gets to come to the party. So all of those things that got circled get to come to the party because they all got invited by somebody. Everything except the 2. So instead of adding them all up, I'm going to be smart and take 24 minus 2 and say that's 22 out of 24. And you caught me. I would have got that one wrong in a hasty moment where I goofed up intersect with union. All right, so who actually had that right in the first place? 22 out of 24. Nice job. Okay. All right. So now I told you I could make them so that probably only 1 or 2 kids get it right. Here's the ultimate challenge. Ready? See if we can do this. Okay. Probability of not C intersect not V union not S. The knots really mess with people's heads. Oh, sure, go with the safe answer of 0 because it just seems like nothing's possible. Doesn't mean you're right. Do you have a guess? Do you have a best guess? Don't say the answer yet. There's still too many people trying. Okay, so if I were on the test, I wouldn't have two different color markers, right? I'd only have a pencil. Although I don't disallow using multiple colored pencils. That's not illegal. But I'm going to just use different shapes on these things because I wouldn't be able to use different colors on a test. So here's not C. Would you agree? I'm going to use triangles here. With that's not C, that's not C, that's not C, and that's not C. Would you agree so far that I've captured not C? Okay. Next I'm going to do, pausing. Okay, now not V. Remember, can't use a different color. So I'm going to use not V is going to be circles. Would you agree that these are all of the things that are not V's? Did I circle all of the not V's? I think I did. Now, do I want where they overlap, as in intersect? Or do I want a big group of everybody? Intersect or union? Intersect. I am intersecting. Where are the two intersecting? The 7 and the 2. How many of you knew the 7 and the 2 were special? Good. Then, where does that union with not S? All right, I got to stick with my I don't have different colors thing. So here's my not S's. Everything that's not an S, I'm going to put a square on. 12-minute warning. Okay, not S's. That's not S. That's not S. That's not S. And that's a not S. So remember, it was the 7 and the 2 that were special. But I'm now unioning that with everything that just got a box. So it was the 7 and the 2 and everything that just got a box. It's all of those. Union does mean a big group, right? It's all the ones I just circled really darkly. That's 13 out of 24. I've done it twice to double check myself. Anybody else get 13 out of 24? Ooh, a bunch of you. All right. I warned you that was a really tough one. Don't stress if you got that one wrong. It wouldn't be that hard. Okay. Let's go look at your homework together. Pause for a second while we pull that up. So here's our review worksheet. I have good news for you. I normally assign every single problem on the review day, but this felt a little long to me. So I am cutting out the very last question, which is this guy. That's quite a few parts. But I would say it this way. If you don't really understand these ones with the probabilities in them, maybe you should do it. I like to think of these as just like, if there's 100 people, this means 4 out of 100 people. If there's 200 people, it means 0.04 times 200, which would be 8 people. I like to change these to how many people there are sometimes. Okay, so if you are not comfortable with these, maybe you shouldn't skip 7. You should try it. Because there could be questions like that on the test. I normally make you do all the questions, so it's your life. I recommend just doing 1 through 6 and taking a look at number 7. And if you're like, yeah, I get that kind, I'm fine, then you may skip number 7. All right, let's look at number 1. The CDC took a survey of 11,631 high school students, and then they were asked whether they consider themselves to be good weight, underweight, or overweight. You think it's wrong to even ask people that? It's an interesting thought. It is. I don't know if that's right to ask, but I guess they did. So anyway, this is probability the randomly chosen person is overweight. Well, Here is overweight. Should it just be 2737? Well, that's not a probability. Did they ever say given? No, then you keep the same what's possible, and what's possible is everyone, which is 11631. If they ever say given, or if they say randomly chosen male, that is making it so it has to be a male is chosen, then you're going to do that deal where you like scribble out everything except the males and then answer with only those 4 numbers on problem C. All right, so part C and D are the more complicated ones because they are a given type question, and so they're not out of 11631. They're out of some other subtotal. All right, I also want to help you with number 2 because even I had a little bit of trouble getting started writing the tree for this. Okay, so imagine for a moment, if I do this, and this is the 3 kids, Gladys, Becky, and Yolanda, then that implies either Gladys is going to make the team, or Becky's going to make the team, or Yolanda's going to make the team. It's like one of the other. That's not how it works. That 2 of them could make the team. So you can't start that way. You could easily get that marked wrong on the test because you started that way. No. The choice really is, if Gladys tries out, she's either going to make it the team or she's going to not make the team. And this was Gladys. And then hers is a 0.4 and a 0.6. They actually never said the 0.6. I can just assume it because they have a total of 100. Then I hope you've got the ability to zoom in because this is going to get a little intense. The red ones are the next kid either making or missing the team. And that's Becky. So the red is Becky. And make and not. Make and not. And her probability of making the team is 0.3, which logically means a 70% chance you will not make the team. 0.3, 0.7. And then last but not least, we're going to do that again for Yolanda. Yolanda's either going to make or not. Make probability for her is 20%. And that means 80% chance you won't make it. And you keep doing that for all of these. I know these are a bit of a pain. There's only one of them. And then once you get all of your decimals down here, it's going to help a lot. So 0.4 times 0.3 times 0.2. Pause while I figure that one out. 0.024. I'll write that here. 0.024. I just arrowed up. Oops. There we go. 0.024 for that one. Drag this over so I can operate it from the board. 0.096, etc. I don't want to fill out the whole thing for you, but I've got it started at least. Now, from there, these questions, try to note when they say given something, then it's not out of everything. Do you get that they say, if they said given Gladys made the team, then this whole part of the chart would be gone? If they said given Gladys makes the team, you know what I mean? Then the only ones that could work would be the ones on the end. There's 4 numbers right there, and those are the possibles. Those go on the bottom. You'd add all 4 of them up, and they would go on the bottom. That's going to be the answer for one of these. Okay. I warned you, not quite as easy as the last couple tests. Definitely do your practice tonight. If you do this worksheet thoroughly and you check it, and you're still confused, tomorrow morning, I do have a morning help time. You could come in and get some extra help. And I would definitely look at the key and be ready to turn this in the Dropbox tomorrow right before you take the test. I'm not going to actually make it due tonight. I'm going to ask you right before the test, hey, go Dropbox it now. Okay? Yes, sir. Okay. Independent and dependent kind of probability goes like this. If I flip a coin, if I got 3 heads in a row, does the next one like depend on what happened before? No. That's independent. If I am reaching in a jelly bean jar and there was like a bunch of black ones, I was going for the black ones, okay? And I grab a bunch out and then I keep them out, do my probabilities change for my next grab? Yes, see, that's dependent. So if you replace the items, that would be make it back into independent. I looked at them, I didn't like them, I put them back in. Now my probabilities are back to the same thing. So it's usually about whether or not they replace the cards in the deck or the beans in the jar. Then if they replace them and they start over again with the same exact numbers, that's independent. And if it depends on what you picked, that's dependent. Yes, sir. Okay, in a Venn diagram, it all depends on how things were set up. Okay, if it has to be a Venn diagram question, but you must be referring to something on the homework.
Yeah, it's the third question.
Read me the third question.
Fourth one is define dependent and independent events. Give examples.
Okay, so it doesn't have to do with the Venn diagram. So if I were you, I'd go with the whole jelly beans in a jar thing or whatever. Okay, no problem. All right, and that's all I have for you for today. Test is tomorrow.